AC generator. It is a mechanical device that converts mechanical energy into electrical energy. Here, this is north and south pole of magnet. These lines show that uniform field is there, which is directed from north to south. This is armature coil, which rotates. This is axis of rotation. These are slip rings. S1 and S2 are slip rings, and B1 and B2 are the carbon brushes. And this is load resistance. The same thing I have discussed in detail. So let's try to understand. So, principle. It is based on the phenomena of electromagnetic induction. When a rectangular coil rotates in magnetic field due to change in associated magnetic flux and induced EMF is developed. That we have already studied, that E equal to minus d phi by dt, where phi indicates the flux and t is the time, and E is induced EMF. Now, let's see its construction. The same thing as we have discussed. It is detailed study. It consists of a rotating rectangular coil ABCD placed between the two poles of a permanent magnet, as I have shown here. Then the two ends of this coil are connected to the two slip rings S1 and S2. Here slip rings are shown. This is S1, this is S2. And the inner side of these rings are made insulated. The two conducting stationary brushes B1 and B2 are kept pressed separately on these rings S1 and S2. So here, if you observe, this is brush B1, this is brush B2, which is pressed against these slip rings to make external contact. Now, the two rings S1 and S2 are internally attached to an axle. The axle may be mechanically rotated from outside to rotate the coil inside the magnetic field. So our purpose is to rotate the coil inside the magnetic field, and some mechanical device is used for this purpose. Outer ends of the two brushes are connected to the galvanometer to show the flow of current in the external circuit. So here I have not shown the galvanometer, but one can show here the galvanometer, which will tell the direction of flow of the current. Now, working. When the axle attached to the two rings is rotated such that the arm AB moves up. If arm AB moves up, then arm CD will move down. Then moves up and arm CD moves down in the magnetic field produced by the permanent magnet, assuming that the coil ABCD is rotated clockwise in the arrangement. Now, we apply Fleming's right-hand rule. The induced currents are set up in these arms along the direction AB and CD. So induced current will flow in the direction AB and CD. So we can say like this. So when a conductor is placed in magnetic field, it experiences a force. So that thing we will discuss. So by applying Fleming's right-hand rule, the induced currents are set up in these arms along the direction AB and CD. Thus, an induced current flows in the direction ABCD. If there are larger number of turns in the coil, the current generated in each turn adds up to give a large current through the coil. This means that current in the external circuit flows from B2 to B1. So once current will flow from B1 to B2, and then next time it will flow from B2 to B1. So after half rotation, arm CD starts moving up and arm AB starts moving down. As a result, the directions of the induced current in the both arms change, giving rise to the net induced current in the direction DCBA. So the current in the external circuit flows from B1 to B2. After every half rotation, the polarity of the current in the respective arms changes. Such a current which changes direction after equal interval of time is called an alternating current. And alternating current is represented like this. So this is positive half, and this is negative half. And equation of such current is given by I equal to I0 sine omega t. Now, let's see the expression for induced EMF and current. So if we write the parameters given, like number of turns are capital N. So N is number of turns. A is the area of each turn. B is magnetic field, and theta is the angle that the coil makes with narrow. And omega is angular velocity. So we can write phi equal to BA N times cos theta, where theta is omega t. So phi equal to NBA cos omega t. Now, induced EMF in modulus will be d phi by dt. So that will be equal to d upon dt. We are taking modulus value, so I will not write minus sign. So modulus of d upon dt of n BA cos omega t. So it will give NBA omega with a minus sign sin omega t, and after taking modulus, it will become sin omega t. So this is E. Now E max will be equal to sin omega t will be 1. So in that case, the value will be NBA omega. And suppose we want to find out I. So I will be E upon R. So that is, this expression can be written as E equal to E0 sin omega t, where E0 is this much. This is E0. So it will be equal to E0 sin omega t divided by R, which is equal to I0 sin omega t. And the maximum current will be I0. Thank you for watching.